So I'm delighted to welcome Sir Warren East to give our 50th Lubbock Lecture. And as you've already heard, this is actually the second time he's done one of these. And obviously it was so well received the first time that we may, in fact, invite him many times again. So Warren is an alum from our department, having graduated from Wharton College. That was a bit of a surprise. He worked for 11 years at Texas Instruments before joining Arm Holdings in 1994, where he became CEO in 2001. And in this role, he led Arm to become the world's leading semiconductor IP licensing company. In 2015, Warren was appointed CEO of Rolls-Royce. He led the company through significant modernizations and through the COVID-19 pandemic. So Warren has been a friend of the department, college, and university for many years. He's executive in residence at the Side Business School, and he has a strong relationship with both research and leadership in our department. So you didn't come here to hear me, you came here to see Sir Warren, so I'm delighted to introduce him to give this talk.
Thank you very much, Clive, and thank you very much, Lord Avebury, for your comments as well, and thank you all very much for coming and listening to this. With that sort of build-up, I'm sort of filled with trepidation about how much I can live up to it, but it's a great privilege to be asked to come here anyway, and it's an even bigger privilege to be asked to come and do it a second time. This is going to be a completely different talk. Although there are a few resonances with the talk that I gave probably in about 2005 or 7, I don't know, 6 was right, okay. I knew it was 5 or 7 or maybe 6, but anyway, some time ago. So on the version of that slide that I sent through, it had a title and a subtitle, and we needed to sort of edit it a bit to fit the format. And so my title was something along the lines of engineering issues in climate change, but the subtitle I had was basically a promising future, but some inconvenient truths beyond the engineering. And if you want a sort of one-line summary and you want to go to sleep now, then that is the one-line summary. I'm also aware of the fact that there's no clock in here, so keeping track of time might be a bit challenging. I'm going to try and remove a watch and keep track of it that way. Anyway, let's have a look at where we're going. First of all, I'd like to do a little bit of sort of context setting and so on, and ask, what the nature of the problem. And then we'll talk a little bit about some of the progress that has been made in technology, which is great, and then get on to some of the inconvenient truths, or as I've politely referred to them here, the challenges ahead. And then I'd like to leave you with an optimistic view, because I'm inherently an optimist about this stuff. I'm not quite sure why that went blank, but there we are. Now, first of all, there's a bit of a health warning. The caution here is data. When you start sort of trawling around all the data that exists around climate change, energy transition, these topics, there are obviously multiple sources of data, but there are agendas out there. Many of them are commercially driven agendas. Some of them are politically driven agendas. And then you've got gross oversimplification amongst our media outlets because they want to get the message across to people at large. And so I think if you put all those three together, then you find that establishing the truth is very difficult. And so this is a health warning. I will be using some data here, but I've attributed, where possible, sources of the data, but please treat any data you see with a little bit of caution. The first thing to talk about then is there a problem in the first place? And here's a little extract from a presentation I gave to the IET when I became president of the IET last autumn, and you have to do a president's address. I talked about the state of the world, and it's pretty grim. There's all sorts of horrible things going on. I am a little bit optimistic about this. I think humans are generally a collaborative species. You wouldn't necessarily know it if you looked at the news at the moment, but generally we are a collaborative species. And in particular, as I'm talking largely to an audience of engineers, then engineers are a particularly collaborative subset of that species. And so I can be a bit optimistic about the fact that there are problems. There's undoubtedly problems going on. First bit of my optimism is, well, of course there are problems going on. If you think about the lifespan of most of the people in this room, it's probably encompassed by the period 1950 to about today. And in 1950, there were 2.5 billion people on the planet. And now there's somewhere north of 8 billion people on the planet. So we've got more people doing more stuff. There's bound to be more stuff going on. There's bound to be more arguments. There's bound to be more consumption of goods, services, bound to be more consumption of energy, more consumption of resources generally. When I get into some of the political things a bit later, there's more consumption of political capital, and there's more over-promising that goes on, and so gradually there's actually more consumption of debt, and infrastructure debts tend to build up, and that's going to happen anyway. That's just a feature of the fact that this tiny world that we live on, in a blink of an eye, in terms of the history of the planet, the population of human beings has gone up by nearly a factor of 4. And so I think we need to bear that in mind, because that isn't that we're doing anything particularly bad. It's just there's more people doing stuff. Now, most people today do believe that there is a climate change issue. Unfortunately, there are still a few skeptical people perhaps out there who try to defend the fact that maybe we shouldn't do anything about it because actually the world has been a lot hotter in the past, and therefore what does it matter? Well, the world has been a lot hotter in the past, and perhaps the world looked a bit like this when it was a bit hotter in the past, and not quite so green. But the other observation I'd make about that particular image is that there are no people. And that's the key issue with the world having been hotter in the past. We talk about cooking the planet, destroying the planet. We're not going to cook or destroy the planet. The planet will be absolutely fine, and humanity will have disappeared in the blink of an eye, because actually it's humans that can't cope with the extremes of climate that we talk about, and in fact was sort of hinted at in the opening presentation this afternoon. So I could say, if the planet's been all that hotter and humans are going to disappear anyway, why bother? Well, that's a picture of my daughter and her husband and her little boy, and that's why I bother. I bother because of providing a future, not really to that generation, but because by the time that little boy grows up, even if we carry on as we are with no adjustments, it'll probably still be fine. And by the time his great-grandchildren grow up, maybe it'll be a little bit hotter, but soon it'll become very unstable, and that's why we care about it. So there is I've put on the side of this slide here, it's a necessity, and that's why I believe it's a necessity. But it's also a once in a long time opportunity. We've been using fossil fuels for forever and a day, since cavemen started having fires. But really, in the last sort of 200, 250 years, we've really accelerated on that in terms of fossil fuels. And we haven't had a change in our energy consumption and the way that we produce energy and move it around for about that length of time. So this is a once in a 10 generations event if we're going to execute an energy transition. And that's why to the young engineers, and we haven't got many students in the room, but if we did have a lot of students in the room, I'd be saying to them, this is a fantastic opportunity for you, because this is a once in a 10 generations opportunity to do something about it. Not many people get the opportunity to live through a transition as important as this, and even fewer get to do jobs where they can actually make a difference and change the world. And that's a tremendous opportunity for young engineers graduating today. It's a tremendous privilege that they have. So enough of context setting. There is actually a bit of good news. Now, wherever you go, certainly around the UK today, and if you travel in mainland Europe, there's a lot more. You see solar farms like this cropping up all over the place. And I could have pictures of windmills as well. So there has been some great progress. And what's really been driving that progress? Well, actually, it's economics. And I stole the image on the left-hand side of this slide from Adair Turner, who was the first chair of Ed Miliband's Climate Change Committee back in 2008. And Adair is very, very bullish about solar. And the reason that he's very bullish is because of the curve on the right, the sort of Moore's law applied to solar panels, and the image that really obviously inspired him, but also I was quite attracted by it, was this thing. This came from a supermarket in Spain. And you know, when you go and visit supermarkets this time of year, you'll find on the way into Tesco some picnic tables and things that you might want to buy a picnic table, or some sun loungers or something like that. And in Spain, this particular time that Adair went there, they were selling solar panels, 500-watt solar panels for less than €100. And that means this is a consumer thing. This is really successful. And a few decades ago, it was, well, it's really quite expensive. We're going to have lots of government grants to persuade people to install these things on their roofs and so on. But we have come a long way, and that's because the great engineering that went to it into that recognized the fact that to be really great engineering, it had to be great economics as well. Let's look at a bit of other good news. We've looked at solar panels. We could have looked at wind turbines. We're going to look at wind turbines in a minute, spoiler alert, and look at electrification of some other sectors, so electric vehicles. These histograms show that actually electric vehicles have grown significantly over time. There's significant numbers of electric vehicles being made and delivered today. The chart on the lower half of the slide, however, when you take those numbers and you divide them by the population, shows that there's a significant way still to go forwards. You know, we've achieved some great volumes, or that industry's achieved some great volumes, but they're tiny volumes really compared with the population that's there. And I'm just later going to talk about some of the reasons why that might present some challenges. But if we come a bit closer to home and look at the UK is in a few places on those histograms. But if you look at electric vehicles in the UK with time, then you can see how in a very short space of time, like now a decade and a half, we've come from next to nothing, really niche enthusiasts, through to 20% of the cars that get delivered per annum in the UK. And two other interesting things about this, the shape of the curve generally, and also the shape of the green bar versus the blue bar, which is the green bar is the fully electric ones. And although the histogram only goes out to 2021, I said I was struggling a bit with the data, and I'll extra bit of data on the bottom of the slide shows that trend has basically continued since 2021. So that's all good news. And I could go on, but I'm not going to, because it's time to talk about some realities. And if we just pick that last topic that we've been on, electric cars, then there are some realities to consider. There is a problem with myths. I was hearing the other day about a study that somebody with a vested interest had obviously sponsored, about how much more damaging for the environment an electric car was versus a diesel car. You get more particulates out of an electric car than you do out of a diesel car. Isn't this dreadful? Well, it may or may not be true. I think you can probably engineer some example to create the fact that it is true, and that's all to do with the tyres that are on the car, and the particulates come off the tyres, and because electric vehicles have batteries in them and they're heavy, the car's heavier than a diesel car, and therefore you get more particulates because the tyres disintegrate a bit faster. Well, has anybody heard of the difference between a winter tyre and a summer tyre? And the variation in how much tyre gets left on the road, and therefore particulates get distributed into the atmosphere, on the difference between a winter tyre and a summer car on the same car, unfortunately turns that into a little bit of a myth. But nevertheless, when we're talking about barriers, public acceptance and reluctance, some of these myths do persist and do get sponsored, and that's one of the challenges. The other one, of course, has been range anxiety, and part of the range anxiety is related to how quickly you can charge a car, and that's fine. People are now moving. If we talk about charge rates, you can stop on the side of a motorway in the UK, and you can have a charger that will charge you at 350 kilowatts. If you've got a 70 kilowatt battery on your car, then that's getting down to a reasonable period of time to charge it. The only trouble with that is that they're few and far between, point one, and the other issue is only a few car models will charge at that rate today, but that will definitely improve. But I think when you get down the slide a bit, you start to get into some of the more meaningful issues, like how on earth are you going to deal with the total amount of energy that you need and produce that extra energy, and how are you going to take it from where it's produced to where it needs to get distributed, and how are you is the infrastructure that you're going to use capable of delivering that energy fast enough, i.e. its power capability. And you can imagine my comments about data and myths and so on. There's an awful lot of nonsense that is talked about in terms of, oh, it'll be all right, we can install all these chargers. Of course we can, but the amount of activity, economic activity, investment and so on that has to happen in the background to enable that is something which then doesn't get spoken about. So, I mean, just a little bit of arithmetic. There are 34 million cars in the UK. On average, each one does about 7,500 miles. And an electric vehicle does between 2 and 4 miles per kilowatt hour, call it 3.5. And that implies you need to generate an extra 72 terawatt hours of electricity in the UK. Now today, our usage in the UK, and we'll see on a later slide, is about 320 terawatt hours. So, okay, but it's more than 20% that we need to take in a single leap. And this is quite a significant step when we get into how impaired the grid is in terms of its ability to move all that stuff around. And I could go on, but you get the picture. Now, the good news is that that's a sort of flavour of some of the things around electric cars, and I could have picked any other thing that we're busy electrifying, and probably come up with a similar list. The new National Energy Systems Operator does actually produce some encouraging reports, and this is good news. Zero carbon at 52% of our usage in the UK, and a peak of 85%, where zero carbon includes wind and solar primarily, a little bit of hydro, tiny amount of hydro really, and about 16% of nuclear, which also counts as zero carbon, and should count as zero carbon, by the way. That's quite encouraging data, until you notice that at the top of the slide it says June. And when you start looking at it on an annual basis, it gets a little bit harder. I mean, this is still not bad. 25% of our usage, this is 2023 numbers, 25% of our usage coming from wind, 4% from solar, 1% from hydro. Go to Norway, and they do a lot more on hydro, by the way, which is a benefit of Norway and the geology and landscape that they have there, which we don't have here. Also, look at the difference between what happens in summer and what happens in winter, both with the wind and with the solar. And remember Sarah's talk earlier about when she gave the example around the wind turbines and the volatility that exists, and the way the volatility is getting worse. So remember that point as well. Then you come to the economics, and wind turbines and solar. I mean, solar is good compared with wind in terms of both capex and opex. But unfortunately, in a latitude like the UK, with a climate like the UK, then the load factor is a lot worse than it is for wind. Not surprising. You can't get something for nothing, so you have to pay for the wind, and you have to pay less for the solar. I mean, I think there are a few implications coming out of this slide, and here I didn't want to sort of clutter one slide with putting everything on it, so I have to ask you to try and remember the gist of what was on the last slide when we come to this one. Sarah's presentation talked about, first of all, huge capacity increase still required. So, it's great that we're generating 30% on an annual basis. We're generating 30% of our energy out of wind, solar, and hydro. But that still means that there's twice as much that we're not generating, because 70% is having to come from other sources at the moment over a year. And I know this is a little bit parochial because I'm talking about the UK, but the UK exists at about 52, well, I mean, we're sat here in Oxford at about 52 degrees north. And actually, when you look at the maps of the world, then an awful lot of economic activity exists in these temperate zones for obvious reasons, because it's actually quite a comfortable climate, and so that's where human beings happen to be, and that's why we have a lot of economic activity in this sort of latitude. The only problem is that latitude means that you get that massive difference between summer and winter, which I referred to on the last slide, and there's nothing we can do about that. That's called nature. I think that's a couple of the issues. First of all, huge capacity. Secondly, massive seasonal difference. And thirdly, as we saw in Sarah's talk, volatility. So what do we do about it? Well, people have talked about storage, and I heard battery storage systems mentioned a couple of times earlier on this afternoon. Now, one of the challenges there, let me tell you, we have a solar farm that is being about to be installed in the village where we live, and it's going to be about a 50 megawatt solar farm. It's over approximately, I think it's approximately 200 acres, something like that. And it's going to have a battery energy storage system. And the battery energy storage system is going to be able to store a massive 2 hours worth of generation from this 50 megawatt solar farm. And it's going to take approximately 1 acre of ground. So you look at that and you think, well, that's not too bad. That's like 0.5%. Okay. But we're just talking about, a minute ago, about the seasonal issue, not the 2-hour issue. And so if you take the same solar farm and say, I want to take 1 month and displace it from the summer to the winter, I then start looking at some data from, say, Clark Energy, who are a supplier of battery energy storage systems. And I look at how much area their battery energy storage systems take. And unfortunately, the arithmetic becomes just mind-boggling. And I've got the arithmetic written down here on my crib sheet. But 1 summer month relates to about 9,000 megawatt hours. And by the time you take the area of the battery energy storage system into account, 500,000 square meters, that's a 4-lane motorway that goes from here to Burford. And that is 150 megawatt solar farm for 1 month. So, batteries are great for what they're good at. But we absolutely need, when it says massive storage required there to deal with the massive seasonal difference, that says, and I was very pleased to hear we had a question earlier in the earlier talk about, shouldn't we be using hydrogen? Shouldn't we be using gas of some kind? Of course we should. Because, and one day there may be a magnificent breakthrough in battery technology. But we can't afford to sit here and wait for that one day to happen. We have to work with what we have and what we can use today. So I would say the implication there are 2 implications. One, the nature of that massive storage needs to be something other than batteries. Hydrogen is not a bad answer, although I did have a discussion with the questioner who pointed out that the round-trip efficiency is 50% at best. But 50% is a lot better than nothing in my mind. And nuclear is absolutely obvious. Now, some of you might know I work for a nuclear fusion company just down the road, because Oxford is like nuclear fusion valley, superconducting valley. And one day we'll have nuclear fusion. But we can't wait for nuclear fusion. And so a bit like we can't wait for the battery technology, let's work with what we've got. Let's also work with what we've got in terms of nuclear. And there's a little bit of discussion about SMRs versus big and so on. You end up with a handful of things, really, and I've gone on long enough about storage, and so I'm not going to talk any more about storage. It's money and physical resources. I didn't go into the money, I just went into the size, but you can imagine what the money's like. Nuclear, there is an issue with public opinion, and I think the good news is that public opinion is turning. The imperative is that public opinion does turn. And because we can't afford to wait for fusion. But of course, that doesn't mean that we shouldn't pursue things like fusion and keep that in balance. Grid infrastructure. I talked about that 50 megawatt solar farm. The only thing that's been holding it up for the last 4 years has been a grid connection. The grid is in a poor state, whichever way, and we had a good sort of, you summarise well the sort of different stages of generating and distributing and so on and transmission. We need to do a serious job of improving on that. I think the other two things in the difficult bucket are some of the sectors which are very hard to abate. Electric aircraft will happen, but they're not going to happen at scale for a long time. And meanwhile, we have to find another solution to that. Cement, great. Thank you very much. Great talk on the buildings, but we're still going to use cement for decades. And there's some great technology around where you embed the carbon in the concrete, and that's good because it's sort of correcting for itself. But you still need to spend a lot of energy to capture the carbon dioxide in the first place before you stuff it into the concrete. So there are some seriously big issues in the difficult bucket, and then if we solve all of this around electrification, that's good. Of course it is, but electrification today in a country like the UK still only accounts for about 20% of the energy that we use. And in some countries in Europe, it's less than that. So there is a difficult bucket of stuff still to happen. Now, I want to talk about just a little bit more reality before I get optimistic. There was a question earlier about the costs of resilience and Ofgem and so on. I mean, absolutely, Ofgem needs to find a mechanism for passing the costs on to where it needs to be paid. The long and the short is that we have to pay for it. We are society. We people have to pay for it. And to deal with that really difficult bucket is going to cost a lot of money. But not dealing with it is going to cost even more. Now, it's very hard to spend all that money because we're not in a great position financially. This is you can see the countries along the bottom there. Germany's actually, obviously relatively strong compared with some of these other countries, and I've heard some very optimistic commentary in recent weeks about the German economy. But most of us are labouring under a huge pile of debt, which makes spending lots of money on infrastructure really hard for our politicians, because our politicians every few years have to give us lots of presents because they want to get re-elected. And that is the system in which we operate. I think that is a serious additional challenge here, where I can't blame the politicians for wanting to give us lots of presents, but there has to be a little bit of tough love. We've all experienced it, or most of us have experienced this as parents. Of course you want to give your kids lots of presents and nice things and all that sort of thing, but sometimes it's time for tough love. And I think we need to embed a little bit of that into where we are. So now I'm going to change tack and talk about business. And this, I hope, is part of the sort of the Lubbock legacy, really. You talked about the picture of your great-grandfather, and up there the words talk about his beliefs around business being, or engineering being, the mainstream bring of our industry, and business being the way to deliver all this. So this is absolutely spot on Lubbock stuff. Some of you, apologies, may have seen me present this slide at an event with the side a little while ago, so apologies if you've seen this one before, but it'll be fairly quick. This is a model of an engineering company, and we've got the engineering company in the middle there, and they're building products, and they're taking some engineering. They're taking some science, doing some engineering on it, turning it into products and services and selling to customers on the right-hand side of the slide. That's sort of how it goes. And you have sort of value going in one direction from left to right along the slide, and money coming in the other direction to pay for it. So it's a pretty simple model. Where does the value come from in the first place? It's fundamentally creativity. It comes from places like Oxford University, and a few other universities as well. But it is creativity, and that's a slightly tongue-in-cheek comment about Oxford University, but it's an important one, and I'll come back to that in a moment. Other folks that have a role in this are the government and investors, because investors invest in these businesses in the first place to get this virtuous circle going. And sometimes, particularly when we're dealing with something like energy transition technologies, which require a lot of money over a lengthy period of time, governments need to invest as well, because individual investors don't have the mandate to do that sort of thing. And so there's a flip side to that, and that's the tax bit. And this is why it's important that business at the top there, when I said you have value going in one direction and money flowing in the other direction, there has to be more money flowing back than there is value going out. Businesses have to make a profit. Capitalists aren't greedy what's-names. They're actually trying to make a profit. And why are they trying to make a profit? A, because they want to repeat the exercise and invest in more products and services for their customers, but also so that they can pay a return to their investors, and that's very important, and they can pay tax to the government. Now, the return to the investors is very important, because the investors can then invest in other businesses and do more of the same. And the investors can pay tax to the government. And the tax arrows are really important, because the government needs to distribute that to the non-business sectors of the economy that we all rely on to make our society work, like health and education and that sort of thing. And that's why there's an investment round here going into the science. And that's why it's important that business makes money, because if business doesn't make money, Oxford University doesn't have any money from the government, and that's not a good thing. So that's the way the model ought to work. Now, the problem is that there are so I think business can deliver, and that's how it ought to deliver, but there are a few issues at the moment, and the issues are around risk and return. And some of these technologies that I've sort of alluded to today, hydrogen storage, for instance, this is still relatively immature. Batteries could get a heck of a lot better, but they need a lot longer to mature. Some of the abatement technologies, carbon capture and that sort of thing, needs time to mature. A lot of these investors have raised tons of money, and some of them have multi-billion-dollar energy transition funds. The problem is that they've got all the money from their investors into those funds, and they've implicitly promised a certain balance of risk and return. And it's in the wrong place for these sorts of technologies. It encourages them to be too risk-averse or demand too high a return from the businesses before they're mature and ready to deliver that rate of return, and therefore the technology development gets stifled on the way. So I think we need to do something around that, around the return and the balance of risk and return. And we also need to make sure that we do the leg on the left-hand side, where governments mustn't forget that they have to invest in that basic science, otherwise the thing just doesn't work in the first place. And that's why I think people like us in this room need to not shy away from pushing these issues. And I spend a bit of my time pushing these issues, both the investor one and the government one. I think there are a few challenges when we get around that sort of investors and government, because the government has to listen to an awful lot of bias and amplification of nonsense from vested interests. Here's a couple of recent headlines, just literally in the last couple of weeks, where clearly somebody is trying to sort of say, oh, don't bother investing in the grid because we've got to use gas anyway. Well, of course, data centers are going to need to use alternative sources of power. And when I was at Rolls-Royce, we talked to lots of data center people about small modular nuclear reactors, and that will be good. But the reality is that actually we will need to provide power to data centers via the grid as well. And then we had a question earlier on this afternoon about what caused the issue in Spain a few weeks ago. Well, as Sarah said, the jury's out at the moment on that. But whichever way the jury goes, undoubtedly this sort of headline is amplification of bias to diss the renewables that the Spanish government are pushing into Spain. So I think those are some additional challenges that we have around making the model work when it comes to business. Nearly finally, I think I've explained that electricity isn't just about renewables. Climate change isn't just about the energy transition. We need to do some adaptation as well. And we had a picture earlier about flood defences around a substation. There's debates about, are we going to invest in pipelines to capture carbon dioxide? Now, this is another thing about like small modular reactors that's, why does it take so long to make these decisions? Of course, we're going to have to capture some carbon dioxide. We're going to continue generating carbon dioxide for decades because we're not suddenly going to turn off fossil fuels. We're weaning society off fossil fuels. And so we do need to capture carbon dioxide. Plus, the difficult-to-abate sectors, like I had on the bottom of that slide a little while ago, cement. Imagine society without cement. Imagine society without glass. Imagine society without aluminium. All of these things create carbon dioxide, and so we need to do that. And then we need to think about how we change our behaviours as well. The second talk was about how we change our behaviours around buildings. We don't have to just do energy transition away from fossil fuels. We have to adapt the way that we live if we're going to deal with climate change properly and recognise the fact that it won't just be an overnight phenomenon. So if I pull them all together, that's roughly a list of what I see as the issues. There's something to be done around business, something to be done around politics. Communications is a heck of a barrier. I'm a little bit worried about the complacency that is engendered from some of the positive media commentary on renewables. Oh, it's great, we're installing all these solar farms, all these wind farms. We're going to be net zero by 2030. Well, what about the other 80% that isn't electrified already? There's no one right answer to all of this. And then there's the engineers and scientists that want to be perfect. We have to work with what we have today, because we can't wait for the perfect solutions of tomorrow. Of course, we'll get better at batteries, fusion, etc., but we need to work with what we have today. And we have to recognise that no one sector can operate independently, no one business can operate independently. It's a ecosystem answer, and we have to do it in spite of the geopolitics. So let me give you a bit of hope to finish. Here's an interesting chap. He's an early 20th century aviator, and he had no problem with ambition whatsoever. Very ambitious chap, did lots of brave things, got in all sorts of aeroplanes that you or I would not get into, and most of us don't really know him that well. If you go skiing in France and go past the airport in Lyon, you'll know him because he's Antoine de Saint-Exupéry. although he was an aviator, he was also a bit of a philosopher, and he's responsible for the phrase that we probably all do know, that ambition without a plan is just hope. So the reason he was able to take lots of risks was because he was a meticulous planner. And he knew what risks he was taking, and he mitigated those risks as much as he could. And so he was quite a successful early 20th century aviator. And I think I've sort of described a situation with a lot of challenges, but I've also described a situation where, you know, we have an engineering profession, we have young engineers that are graduating into the profession today. It's a great privilege for them to be able to make an impact on this. We do have most of the technology required. We don't have to wait for the even better answers. We have technology that works well enough today. Engineering will certainly make it better. We need to enable business to deliver it, because there was another earlier question about, you know, should we be pursuing 100% net zero, or isn't 90% better because of the 80-20 rule or whatever? Well, actually, if business delivers it, then economics will be the answer to that question. So business will deliver it. Energy transition and climate change mitigation, obviously the topic of this afternoon, but there are other big issues out there for human beings to deal with, and we have to put it in the context of those other big issues. We have to recognize that we can actually reinvent some of the stuff that already exists and use stuff that we have today. There's also been quite a lot of commentary around the Tony Blair report a few weeks ago. Now, whether you believe Tony Blair was a bit deliberately mischievous, or somebody being deliberately mischievous, I mean, it was a bit surprising if he wasn't being mischievous, because here's a chap who's very experienced in dealing with the media. But actually, if you read the foreword that he wrote to the report, the media blew the one phrase out of all proportion and mangled it completely. And he should have known they were going to do that. But, you know, they still mangled it. And, you know, of course, a global solution is required. And what Tony Blair was talking about was the need for a global solution, and the fact that, you know, we have to accept the fact that we're not all in the same place all the way around the world at the moment in terms of penetration of some of this technology. So we do need that global solution. But in my experience, when necessity is the mother of invention, stuff happens. So here's my personal journey. I went into the silicon industry when I left here, and in the early 80s, and I worked on the chips that are on that wafer on the bottom of the picture there. It's a 4-bit microprocessor, and each chip is about the size of your fingernail, and each chip has 8,000 transistors on it. And when I left ARM about 12 years ago, they gave me the wafer on the top of the slide there, and each chip is about as big as your thumbnail, and each chip has 2.3 billion transistors on it. And so in the space of 30 years, because that was only, I chose the second half of a career, but in the space of 30 years, that's what human ingenuity and engineering achieved. When I left Rolls-Royce, I was determined before leaving that we would demonstrate some electric flight and ideally break a speed record, which we did. And that's a sort of, you could say that's analogous to the small wafer on the bottom of the slide with 8,000 transistors per chip. And the question mark is what happens in 30 years' time to a difficult-to-abate sector like aviation. I'm optimistic because of my personal journey, which demonstrates that ingenuity that exists amongst the engineering community. And that's all I had by way of talk. I'm very happy to answer any questions.